Okay, so for this strange question that we have here, there's a few strange questions about moments from these Edexcel questions that they've produced. I wouldn't worry about them too much, but this one's kind of weird. So it says 2 identical 5-meter light seesaws are joined at their ends. Robert, who weighs 80 kilograms, stands on top of the joint. The distance between Robert and each of the pivots is 2 meters. So these are 2 meters, which means these must be 3 meters. And what else did it say? Poppy and Quentin stand on the 2 remaining ends of the seesaws, as shown in figure 4. Poppy weighs P kilograms and Quentin weighs Q kilograms. The system is in equilibrium. So this is a very odd question. And what I want to think about here is, rather than diving in straight away with like just trying to take moments, I want to kind of think about what's actually happening here, right? You now actually, for once, you're going to imagine that you're a person rather than a beam. And I want you to imagine that you're Robert, and that, I don't know, let's say that Quentin, because he's a boy, he's probably going to be bigger than Poppy, right? And let's pretend that Poppy is this like small, she's really light, and that you're Robert, who's got 80 kilograms, and you're stood with one leg on one seesaw and one leg on the other seesaw, okay? Both of these seesaws, we can see, is in equilibrium, so they're completely balanced. If you were stood there, and let's say I've got Quentin over this side and Poppy over on this side, what would you do with your legs, do you think? How do you think you might position yourself to keep it balanced?
Shift the weight on one side.
Good. You would shift your weight to one side. Which side would you shift it to? No. If you shifted it towards Poppy, she's going to go flying up in the air. Okay? You would need to shift your mass towards Quentin. Okay? How much force do you have to play with? How much force do you have to distribute? You have your ATG, okay? So your ATG needs to be shared, but not equally. The reason it cannot be shared equally is because they haven't told us that Poppy and Quentin have the same mass as each other. They're going to have different masses, so we know that the ATG that we have in the middle here is going to have to be shared in some kind of mixture. Pardon? ATG is Robert. Robert is 80 kilograms. 80 times G.
ATG.
Oh, no. Oh, dear. Okay, so this is actually just a completely bizarre question, especially because of the fact it's been rounded to a whole number. Like, why? Anyway, so we've got Poppy's and Quentin's here. So I'm going to draw them as 2 separate ones to begin with. So for this one, I've got Poppy's weight, which is going to be PG. And I've got a normal reaction, but whatever really. And I've got here Robert's weight. But this isn't all of Robert's weight, is it? This is some of Robert's weight that he's pushing on that side of the seesaw. So if I want to say sum of Robert's weight, what shall I say? X. So I'm going to just say X multiplied by ATG. Sum of Robert's weight. And this distance is 3 meters, and this distance is 2 meters. I'm actually just going to draw the next one as well, okay? So now I'm going to draw the second half of it. This is, that was Poppy and that was Robert. I'm now going to draw the other one where I've got Robert here and I've got Quentin here. So this is 2 meters, this is 3 meters. Here is Quentin's weight, which is QG. Now this is the part I'm interested to know in. How much, if I'm putting X ATG on that side towards Poppy, how much do I put on the other side?
80 minus ATG minus 1.
Yeah, ATG minus X ATG. Or you could think, the way my brain thinks about this is I would say, well, if this is X, this one would be 1 minus X, lots of ATG. Or the other way of thinking about this when you expand the brackets is it's ATG minus X ATG. It's the weight that Robert has in total minus the weight that he's putting on his leg to balance with Poppy. Okay, so you can either use this or you can use this. For me, I just see if that one's X, that one has to be 1 minus X, so that together, these two things here, what do these two things here add up to? ATG. They have to add up to ATG, because that's the weight that he's got. The X is the thing that's going to decide how much is being put on each bit. Now, we don't need to know this, but what did we think that X would be? What kind of number do we think that X would be if we said that Poppy was lighter? It would be smaller. We'd probably imagine if she's smaller, it would be like 0.4 or 0.3, because he's putting a smaller proportion of his weight on that. This is the whole question done. Okay, this is the whole question finished now because I'm just going to take moments here. I can clearly see that 3pg equals, just from doing 3 multiplied by pg, equals 2x 80g. I can cancel the g's, so I get 3p equals 160x. And here I've got, so I've got 2 multiplied by 1 minus x 80g equals 3qg. So I can cancel the g's here and here. And then that's 160 multiplied by 1 minus x. That's 160 minus 160x equals 3q. Yeah? And now I'm just going to put these two equations together because I know that 160x is 3p. So I get 160 minus 3p, because 160x is 3p, is equal to 3q. So 160 is 3p plus 3q. And I want to divide everything by 3. And 160 divided by 3 to the nearest whole number, which is bizarre why it has to be to the nearest whole number, is 53. So I get 53 equals p plus q. Divide by 3. It's just a silly question.
So,
Yeah.
I did that, but first time round, what I did was I took moments about the first pivot point, right?
Yep.
So I forgot about Quentin, and I just did Robert and Poppy. So I said 2 times ATG
Yeah.
to 3 times PG, and Poppy's weight.
Yeah.
And then I got 53 for that, and then I just wrote on the side, I was just like, if it's in equilibrium, then both will equal that, because the distance is the same as well.
There are lots of different ways about doing this one.
I'm not sure if that was right.
I don't know if that is the right way. I think if you haven't taken into account Quentin's weight, I'm not sure that that's necessarily gonna. Like I'll have to have a look at the way that you did it, because the mark scheme also did it in a different kind of way as well. But for me, this was the way that made more sense, because I stopped and I thought, what's this problem about? He's not putting 40g on one leg and 40g on the other leg. He's clearly having to like distribute his weight in a particular way. As soon as I had that idea of distributing his leg in a different way, weight in a different way, I saw it as 2 seesaw problems that were just attached together. And then it kind of works out like that. But it's just a very bizarre, I've never, ever seen a question like this. So it's kind of, especially the fact that to the nearest whole number, why couldn't they just say, show that 3p plus 3q equals 160, or like p plus q equals 160 over 3? And we'll never know the weights of Poppy and Quentin either, because we don't know how he's distributing his weight with both of his legs. That's why it's an odd kind of question. Okay, was there any other ones from the Rigid Bodies booklet that you wanted to talk about then? The May 2009, okay. This is exactly the one the other class wanted to talk about. Now, I'm imagining there was only one bit that you didn't, was it the whole bit you didn't like, the whole thing you didn't like?
I think so. I think once I couldn't work out A, I just gave up.
Oh, you can't do that in questions. You can't give up on part A. You can do all of this. Okay, let's do this one together as well, and then we'll do some new bits and bobs, and then we'll finish this half of the moments topic, which is the horizontal one, and then we'll go on to the mixed ones, okay? So I don't think there's any really much information in this question apart from, is there anything that's different? No, we've got it supported by 2 vertical ropes. Okay, I better add in here, this is the tension at P, this is the tension at Q. I don't like using a red pen, so I'm going to change. And it says AP is 0.3, BQ is 0.3, uniform rod, 2 meters. Okay, so the whole thing is 2 meters. So what's this distance in here? 1.4. Okay, that's good. I think that's it. The gymnast is 50 kilograms, so I'm going to change that to a 50G. And it's a uniform beam. So in the middle, it's 20G for the uniform beam. I think that's everything we've got there. And there's this weird bit. It says that the gymnast is modelled as a particle is being attached to the beam at the point X, where Px is equal to X. And this thing here, I'm just going to underline that because I think that might be useful. The beam rests in equilibrium in a horizontal position. Show that the tension in the rope attached to the beam at P. Okay, so if it's at P, where is the best place to take moments from? Good. We'll take moments at Q. So I'll make that a bit smaller so I've got a bit more space. We're going to take for first part, we're going to take moments at Q. If we take moments at Q, then we're going to eliminate that tension at Q and we'll have everything like this. So we better think about what the distances are from Q. What's the distance between Q and the 20G? 0.7, because it's in the middle of the whole thing, and so that's 1, or you could say it's half of the 1.4. And what's the distance between the gymnast and Q? Good, 1.4 minus x. If the whole thing is 1.4, and that's x, it's 1.4 minus x. So that's 1.4 minus x. And I think that's the only stuff that we need for this moments about Q that we've got there. So we're just going to say 20g multiplied by 0.7 plus 1.4 minus x multiplied by 50g. So that's the 20g times 0.7 and the 50g times 1.4 minus x is equal to 1.4 TP, right? This is 14g plus, let's just work this out for me, please. Anyone got their calculators ready to go? 14g plus 50g times 1.4. Oh, my calculator's running out of battery. So that was 14g plus 70g minus 50g x equals 1.4 TP. And then all we need to do is work out all of the number bits in terms of g and divide everything by 1.4. So that's 84g divided by 1.4, which is 588. And then you've got 50g. Oh, my calculator is so on its last life. 50g divided by 1.4, and you get minus 350x. It's not. No solar panel on these ones. Then it wants you to do the same thing for them. That's exactly what they wanted. Look, 588 minus 350x. Then you're going to do for the second part. There's two ways of doing the second part. Anyone got any suggestions of what they think is the best way to do it? I probably would resolve up and down here. So we know for part B, when you resolve up and down, we know that TP plus TQ is equal to 70g, which is the 50g and the 20g together. So that means that T, what am I looking for? Q is 70g minus this thing, which is 588 minus 350x, which ends up as being 70g minus 588, 98 plus 350x newtons. Okay? So we've done A, we've done B. It then, this is the part that I think the other class had a problem with. It then says, hence find, justifying your answer carefully, the range of values of the tension which could occur in each rope. When you hear range, what are some of the things you think about? Inequalities. You think of inequalities because the range of something is like, oh, it's greater than 12, it's less than 15, but greater than 6. So I then go back to this thing that I've underlined here. It makes me think, well, there's a range of values that x can be. So there's obviously going to be a range of values that the tension can be as well. The smallest thing that x can be is 0. It can't actually be 0, but so we're going to pretend that it can be 0, and we're going to pretend that it can be 1.4. And that should tell me what the range of values can be for the tension. So for part C of the question, if x is equal to 0, the tension in P, using this one here, is 588. If x is equal to 1.4, the tension in P is 588 minus 350 times 1.4, which is 98. Okay? If x is equal to 0, the tension in Q is 98. And you can pretty much guess now that if x is equal to 1.4, because it's balanced, the tension will have to be 588. And you can do 98 plus 350 times 1.4 and you get that. So that tells me that the range of values that the tension could occur in each rope, the tension in P has got to be bigger than 98 and less than 588. And the tension in Q has got to be bigger than 98 and less than 588. That's it, okay? And that's because the gymnast can like vary along. And if you just sort of think to yourself, as the value of x increases, then the value of the tension on Q is going to increase because it's getting closer to the tension in Q. And if x was equal to 0, that's when the tension in P is at its highest that it could possibly be. It then says, given that the tension in the rope attached at Q is 3 times the tension in the rope attached at P, find the values of x. So which one's bigger? Q is 3 times the one at P. So that means that the tension in Q is 3 times the tension in P. So you're just going to solve an equation. Tension in Q is this. That's 98 plus 350 x is equal to 3 times 588 minus 350x. And you just solve the equation. I'm not going to do that bit, okay? Every single year people get confused on this question because of this range of values and it feels weird and different. But it's not weird and different. You just got to try and extract the information in the question that seems different or notable that we've got there, okay? Any other questions from these moments ones, or indeed from this as well? June 2014? Yeah. On these ones, that will be going over it when we do correlation. Yeah. June 14, did you say? No. You're doing it with Miss, aren't you? Okay, this looks fun. Should we do this one as well? Okay. AB has a weight W newtons, length 4 meters. So I'm immediately going to chuck the W on there. It's held in equilibrium in a horizontal position by 2 vertical ropes attached to the beam. One is attached to A and the other is attached to C. As shown in 3, model uniform rod and weights attached to 3. Okay, this is it. The tension in the rope at C is double the tension in the rope at A. So this tension is double this tension. Find the value of D. So for part A of the question, resolving up and down, we get that 3T is equal to W. Then if you can take, we're going to need to do both because we've got simultaneous equations, we've got loads of unknown things. Then I'm going to take moments. Where I would take moments from is I would take moments about A because my distance is already given as D, so I think it makes sense to take that. When I take moments about A, I will have W multiplied by 2 because it's halfway equals 2T multiplied by D. Now, I know that 2T I can find in terms of W because T is W over 3. So 2T is 2W over 3, or 2/3 W. So you get 2W equals 2/3 W D. Cancel the W's out from both sides. So then you get 6 over 2, D is equal to 3. It then says a small load of weight kW newtons is attached to the beam at B. So I'm going to add that in. There's kW. And it remains in equilibrium. The load is modeled as a particle. The tension in the rope attached at C is now 4 times the tension in the rope attached at A. So I'm going to do this in a different colour. It's now become 4T that we've got here. Find the value of K. Well, the value of D hasn't changed, has it? The value of D is still 3. So for that second part of the question, I'm going to do the same process. I'll resolve up and down. So this time, it looks like I'm going to get 5T equals W plus KW, just in case I need that. 5T equals W plus KW. And I might factorize that. I don't know if I'm going to need that. It wants me to find the value of K. Okay, so I would take moments about... Any suggestions of where anyone would want to take moments? A, okay, let's take moments about A. Same kind of process. I would get 2W plus 4KW. So that's 2 times W plus 4KW equals, how much was the tension? 4T times by 3. So you end up with 2W plus 4KW equals 12T. Now, there's many different ways you could go about doing this one. You could either find out what t is and then substitute it in, and the w's will cancel. That's probably the way I'm going to do this. So what did I say? T is equal to 1 plus k w over 5. So here we get 2w plus 4kw equals 12 times this, which is 12 over 5, 1 plus k w. The w's all cancel. There's many, many ways you could do this. So you get 2 plus 4k equals 12 over 5 plus 12 over 5k. And then the last bit of equation solving there should give us the right answer, I hope. And someone's going to confirm if this is right. So we've got 4 minus 12 over 5. So you get 1.6k, 12 over 5 minus 2 equals 0.4. So k is 0.25. So sometimes you won't ever be able to get numbers. Sometimes you will have to do two things that have got unknowns and unknowns, and you just do simultaneous equations with them. You may have come up with different simultaneous equations here. You may have come up with, you could have taken potentially moments about b, so you didn't have k in at all. That's probably a slightly more efficient way, but any of them work, okay?